everyone. I am Sujata Singh, Faculty of Chemistry. I welcome you all to the official YouTube channel of SRN International School. In this video, I am going to discuss the topic Physical Equilibrium for grade 11. So let's begin with the topic. Physical Equilibrium. Physical equilibrium is defined as the equilibrium between two phases of the same substance when the rates of forward and reverse processes are equal. For example, the evaporation of liquid water in a closed container. So here, the rate of evaporation and the rate of condensation becomes equal at equilibrium. Phase transformation. The characteristics of system at equilibrium are better understood if we examine some physical processes. The most familiar examples are phase transformation processes. First is solid-liquid equilibrium, where the forward process that takes place is melting, and in the backward direction, the freezing process occurs, and the equilibrium is established. Second is liquid-vapor equilibrium, where in the forward direction, the process vaporization occurs, and at the backward direction, condensation occurs. And in the third, that is solid-vapor equilibrium, the forward process that takes place is the sublimation, and in the backward direction, the solidification occurs and an equilibrium is established. Physical equilibrium is also considered as a dynamic equilibrium, and it is a state where the rate of forward as well as reverse reaction becomes equal. It is due to this dynamic equilibrium stage that there is no change in concentration of various species in the reaction mixture. That is, the concentration of all the reactants and products remain constant. Solid-liquid equilibrium. For example, ice and water. So when they are in equilibrium, they will be at only particular temperature and pressure. So for example, when you consider an ice and water, then they will be in equilibrium at 0 degrees Celsius. Okay. So for any pure substance, the temperature at which solid and liquid phases are at equilibrium is called normal melting point or normal freezing point. Liquid vapor equilibrium. It is such a phase equilibrium where rate of one phase change is equal to the rate of opposite phase change. And when it occurs, these two phases exist at the same temperature. For example, if we consider water in a liquid phase and water in a vapor phase, so they will be an equilibrium, and in this case the rate of evaporation or rate of vaporization becomes equal to the rate of condensation. So other examples of such physical equilibrium, that is liquid vapor equilibrium, is evaporation of bromine. Bromine in a liquid form forms the bromine in a gaseous form in a closed container, and then they come to an equilibrium. And here the rate of evaporation and rate of condensation becomes equal. So at equilibrium, the pressure exerted by the water vapor at a given temperature remain constant and is called equilibrium vapor pressure of water, or simply vapor pressure of water. Similarly, we find in the case of iodine solid converting to iodine gaseous. So here also an equilibrium establishes, and here the rate of sublimation becomes equal to the rate of solidification. Solubility equilibrium. It is actually an equilibrium which involves dissolution of solids in liquids. So when you take a particular solute and dissolve in solvent, you get a solution. So solubility equilibrium is a dynamic equilibrium between a solute and a solvent in a saturated solution in a closed system. So in this case, the rate of dissolution, that is dissolving substance, becomes equal to the rate of crystallization. So here we see like the barium sulfate is when added to water, then the solution becomes saturated when all the barium ions and sulfate ions are taking place, all the spaces that is there between the water, and the solid salt remains at the bottom. Now, in this case, we find that there is an equilibrium established between the barium sulfate in a solid and the barium sulfate ions in the saturated solution. So, such a dynamic equilibrium establishes when there is when there is a saturated solution. So, this is called as solubility equilibrium. So, let us talk about equilibrium involving dissolution of gases and liquids. For example, soda water bottle. So if you take a soda water bottle which is sealed, it becomes a closed system. Now inside this we have carbon dioxide gas dissolved in water and carbon dioxide gas above the surface of the liquid. Now there establishes an equilibrium between the molecules in the gaseous state and the molecules in the dissolved state, that is dissolved in liquid under pressure. So this equilibrium is governed by a law called as Henry's law, which states that the mass of a gas dissolved in a given mass of a solvent at any temperature is proportional to the pressure of the gas above the solvent. Thank you for watching this video. Please like, share and subscribe our YouTube channel.